Hi guys, this is my video on how to create A.G.I. I'm going to try to make it really short and fast as possible. So the objective function has to be to maximize impact. I've established why in the previous videos, you probably check that out. Okay, so how to achieve this impact maximization? So the following process has to happen. So whenever a system sees something impactful, it has to just not do anything, and when it's not seeing anything impactful, it just has to do some random stuff so that the change of the so as to change the status of the environment. And you know say for example, if it is actually perceiving something new and interesting, like watching a movie, or seeing a lot of activity in a room, the system has to probably just sit back and just watch it. Whereas if it's bored, if there's no proper input, if it's seeing the same thing again and again, it probably has to just shake its limbs and move around and do something, so that some sort of a change happens in the environment, and then it makes some noise and it makes some other kind of stuff, and it makes some kind of an impact, right? And then so this is the most basic of things, and then more sophistication to this basic process can happen, and can happen if we allow the system to evolve, and and that way we get more sophisticated intelligence and all that. Okay, so I'll tell you how again this happens, right? So this process, right, just when you see there is whenever it is perceiving or whenever it is sensing something impactful, it should not do any output action, and whenever it's not perceiving any impactful thing, or whenever it is getting any negative things like pain or boredom or blank inputs, it has to change the output system, right? So now the question becomes, what is an impactful input and what is a non-impactful input, right? So I'll tell you what, you don't have to we don't have to worry anything, try to classify inputs as impactful or not. See, a normal Hebbian learning, a normal Hebbian neural network with associative learning, that thing does this automatically on its own, because whatever input is causing the output action is the boredom input, or plain input, or non-impactful input, or a loss of impact input. Whatever input is not taking the activation to the output neurons of the brain, that is the impactful input. And typically the difference here is when it comes to neuroplasticity, it's not natural neuroplasticity. When it comes to crossing the resting potential, and then crossing the activation threshold, it happens in two ways, right? It happens in spatial summation, or it happens via temporal summation. Temporal summation of synaptic inputs, that is typically the situation that's associated with a non-impactful input, or a boredom input, or a same old input, or a pain kind of input. Whereas if it's a spatial summation input, that is typically associated with a new pattern that the agent is sensing, and that leads to associative learning and all that. Because when spatial summation happens, what happens is synapses connecting to one particular neuron from two different regions are getting strengthened, right? So that way an association of concepts, association of items which is sensed from two different regions of the brain is getting associated. So that is how you get the pleasure versus pain classification, and that is how a simple Hebbian neural network, which is the brain with synaptic plasticity, automatically does the classification of whether it's a pleasurable input or a painful input, right? So that classification happens, and like I said, like if you think about it, if it's temporal activation, what it typically means is the activation is coming from the same neuron several times, and then that is causing the activation to flow. Okay, So this is the case where you are just bored, you see the same old empty room, there's no object, there's nothing new moving around the room, and you're bored, right? So that's where this the activation comes from the same presynaptic neuron to the postsynaptic neuron, and then that quickly goes on to the output region. Whereas if a spatial summation is happening, that's when the agent is sensing different new things coming from different regions, and then that spatial summation is, leads to like I said, associative behavior. And what spatial summation typically does is it just keeps the activation flow away from the output. Okay, so this way it's achieved, like I said, impact maximization is achieved this way, and it's achieved in normal Hebbian learning method. And then all that's left to do is just allow the neural network to become more sophisticated by forming its own regions with different resting potential, different number of neuronal density, different neuronal connections, and things like that. So if you just keep experimenting with these parameters that I've just told, a simple Hebbian neural network with associated learning can get to general intelligence. It's like associative learning is not just two objects getting associated, it's also sound getting associated with the face, the concept getting associated with this and that and this and that. So if you're interested in this, you should probably just watch other videos in which I've described the whole thing in detail, but it takes it's very time consuming. So this is something that I made it really short so that people just stay and watch on and all that. So like I said, we already have what it takes to create A.G.I. We just need to start coding. A bunch of us has to just start coding, and first try to create a very small worm brain with the Hebbian learning. And what it has to do is just demonstrate a little bit of associative learning and a little bit of impact maximization, where whenever it sees something new, or typically what is new is impactful, right? Because the same old stuff is if there is no impact happening around, and if it's the same thing that you've seen before, it gets you bored. And with the same old blank room where you don't have a television or anything, you get bored, right? So those plain old stuff is just non-impactful things. And then whenever you see something new movies, new people coming in, new thoughts coming in, those are just new and pleasurable things, right? So yeah, so that's the gist of it. And like I said, we start from a very basic neural network, and if we are able to achieve impact maximization with the proper Hebbian learning, and we demonstrate associated learning with spatial summation, we can just go on to build from there, and keep building, allow the network to evolve, and then get more sophisticated levels of intelligence. That's a simple idea. It can be done. A.G.I can be created very, very soon, with this simple idea. There's no need for reinforcement learning or deep learning or backpropagation or all the other bullshit that's doing other A.G.I companies are claiming to do, such as DeepMind or things like that. Numenta have little respect for them, but every other company is just bullshit. So anyway, watch my other videos. This is the way to create A.G.I. And so yeah, and then come down to the coffee shop, and then so we'll try to create a new A.G.I research company here in Chennai. Okay. Now I want to quickly add that every single thought that we're able to generate, right, not just us, even the most primitive animals, whatever goes on in their heads, in their brains, every single thing can be explained with associative learning, right? And I've explained how the associative learning happens and how concepts become associated with each other. That mechanism, that neural mechanism, actually explained in other videos, so you have to also sort of see that and read the description and find my other blogs, and so if you do all this, you'll get the complete picture here, right? And so like I said, the challenge here is just allowing making the neural network to evolve and form its own regions. See, for this we have to obviously take inputs from a lot of inputs from neuroscience, and use that to let our own systems evolve. Say for example, if this activation keeps flowing a lot to that particular region. That particular region, you get more neuronal density, and the neurons get more connectivity with each other and things like that, right? Those kind of things we'll have to experiment and see how the network evolves. That is the only challenge. And then this evolving only makes the system more sophisticated. But even the basic level, right, a simple impact maximization and a simple associative learning thing, that itself we can just call it as AGI. It's just that if we want to achieve more sophistication, we obviously have to have more neurons, like hundreds and billions of neurons, maybe into our system, and then the connectivity between them and things like that. And then so that's the challenge, right? All the computation power required on for those things, those are the other kind of challenges. But AGI, it's really just achieving associative learning properly and then impact maximization. So that's the worm brain, and after that it's all just more sophistication, more complexity, and it's all, but it's all just doable. It's all just, you just keep on experimenting, and then and you just keep on trying and trying, and eventually we'll get some level of sophistication. So that's it. So just watch the other videos. That's all I wanted to add here.